Units. What are the units?
Units, ma'am. Ultraviolet, 400 and 350 meters ultraviolet,
Ultraviolet radiation is invisible spectrum.
ma'am.
Ultraviolet radiation is invisible spectrum. Is it?
Um,
Okay. Tell me what is absorption?
ab- Absorption,
Hmm.
ma'am.
What is transmission?
Um, Transmit. Don't know, ma'am.
Okay. To which wavelength of light is the crystalline lens sensitive for?
Ma'am. Uh,
Which wavelength of light is crystalline lens sensitive for? Do you know the answer?
don't know, ma'am.
Okay. What did you prepare and come for the exam? Only presentation.
Ma'am.
Okay. Fine. Go. You have to go back and read a lot.
Okay, ma'am. Thank you.
Nancy, you can start your presentation.
Good afternoon, ma'am. Good afternoon, sir.
Good afternoon. You can start. Share your screen.
Myself, Chansey. Today, my topic is mirror. Mirror. A mirror is an object that reflects an image. Light that bounces off a mirror will show an image of whatever is in front of it. When focused through the lens of the eye or a camera, mirrors reverse the direction of the image is an equal at opposite angle from which which the light hinges upon it. Types of mirror: plane mirror and curved mirror. Plane mirror. A plane mirror is a mirror with a flat, reflective surface. For light rays striking a plane mirror, the angle of reflection equal to angle of incidence. The angle of incidence is the angle between the incidence ray and the surface normal, an imaginary line perpendicular to the surface. Therefore, the angle of reflection is the angle between the reflected ray and the normal, and a collimated beam of light does not spirit out after reflection from a plane mirror, except for diffraction effects. A plane mirror makes an image of objects in front of the mirror. These images appears to the behind the plane in which the mirror lies. A straight line draw from part of the object to the corresponding parts of it. Images makes a right angle with an bisected by the surface of the plane mirror. The image formed by plane mirror is always virtual, uh, meaning that meaning that the light rays do not actually come the image upright and of the same shape and size as the object it is reflecting. A virtual image is a copy of an object formed at the location form from which the light rays appear to come. However, the image is is a laterally inward mirror image of the object. If a person is reflected in a plane mirror, the image of his right hand appears to be the left hand of the image. Curved mirror. A curved mirror is a mirror with a curved reflecting surface. The surface may be either convex, bulging outwards, or concave. Most curved mirrors have surface that are shaped like part of the sphere, but other spaces are sometimes used in optical devices. The most common non-spherical type are parabolic reflectors found in optical devices such as reflecting telescope that need to image distant object. Since spherical mirror systems like spherical lenses suffer from spherical aberration, destroying mirrors are used for en- entertainment. They have a convex and concave region that produced laboratory destroyed images. They also provide highly magnified or highly dimensioned images when the object is placed at certain distances. Two types of curved mirrors, concave and convex. Convex mirror. A convex mirror or diverging mirror is a curved mirror in which the reflecting surface bulges towards the light sources. Convex mirror reflecting light outwards. Therefore, they are not used to focus light. Such mirrors always from virtual image since the focal point and center of the curvature are both imaginary points inside the mirror that cannot be reached. As the result, images formed by these mirrors cannot be projected on the screen. Since the images is inside the mirror, the image is smaller than the object, but yet larger as the object approaches the mirror. Uses of convex mirror. The passenger side mirror on car is typically a convex mirror. In some countries, these are labeled with the safety warning objects. The mirror are closer than they appear to warn the driver of the convex mirror. Destroying effects on distance participation. Convex mirror are peripheral in vehicles because they give up right and through dimension image and because they provide a wider field of view as they are curved outwards. These mirrors are often found in the hallways of various buildings, commonly known as hallway safety mirrors, including hospitals, hostels, schools, stores, and apartments buildings. They are usually mounted on your walls or ceiling where hallways instructed each other, or however they make sharp turns. Concave mirror.
Jansi, your time is up. You have to stop.
Thank you.
Jansi, tell me three differences between concave mirror and convex mirror. Jansi,
Madam,
three differences between concave mirror and convex mirror. My dear,
the surface may be either convex.
okay, which mirror magnifies the image? A plane mirror, a convex mirror, or a concave mirror? Or three of them?
Ma'am,
Which mirror will magnify the image? A plane mirror, a convex mirror, or a concave mirror? Or all three of them will magnify? What is right? Jansi, which mirror is used in vehicles as a rear view mirror?
Concave mirror, ma'am.
Sure.
Yes, ma'am.
Why a concave mirror is used?
Sorry, ma'am. Convex mirror, ma'am.
Why? Why not a concave and a plane mirror? Jansi,
Ma'am,
why are you silent? If you know the answer, say it. Otherwise, you can say, I don't know. It's
I don't
fine.
know, ma'am.
You don't know.
Yes,
Okay,
ma'am.
tell me the difference between a mirror and a lens. Don't know?
Yes, ma'am.
Okay, don't know. Okay. Okay, one last question. How will you identify whether it is a lens or a mirror? Simple question. I have given you a transparent optical surface. How will you identify it as a mirror or a lens? Jansi madam.
Hello, madam. Hello.
Jansi.
Madam.
Answer. You have no idea?
Yes, ma'am.
Then what did you prepare for the exam? You tell me one topic, I'll ask you. Just copy pasted the content and you're just reading the slides. That's it, over. Exam over. Okay, Jansi, silence shouldn't be your answer. Okay, go back and read. And Krupakar, you can start your presentation.
Okay, ma'am.
Jansi, stop the screen sharing.
Okay, ma'am. Thank you, ma'am.
Am I audible, ma'am?
Yes, you're audible. You can.
Okay. Good morning, ma'am. Good morning, sir. Today my topic is reflection of light. Coming to the content, introduction, reflection of light, loss of reflection, regular and irregular reflections. Introduction. How do we see the light around us? We probably think that our eyes, which are helping us to see the things around us, but in the darkness, we can't able to see anything. The reason is light. Reason being the light. Without the light, we can't see anything. So, where does the light come from? Light is an Light comes from illuminous objects like bulb, sun, stars. These are illuminous objects which emit light. And there are luminous objects such as tables, chairs, moon, planets, and many things around us. For example, there is a moon we can see in the darkness. That is due to because of reflection of light. Simply saying, reflection of a light simply refers to bouncing the light from some surfaces. Coming to the reflection of light, a simple explanation: the light, the light from source The light from the source struck to an object bounces itself to our eye. Then we can see an non-luminous objects. A light hits an object and we can see the reflection from our eyes. And in other case, in a mirror, we can see an image formed in the mirror, but in darkness, we are not able to see the image. This is due to the reflection of light. Now, let's see the procedure. Let's see how the reflection of light done. A single ray that falls onto a mirror, that ray we called as instant ray, and the point where the instant ray falls is called point of instance, and the ray reflect back, that ray we called it as reflected ray. And we have an imaginary line perpendicular to the mirror, we call it as normal. Normal is used for angles, to determine angles. When the angle of incident ray makes with a normal, we call it as angle of incidence, and the reflected ray forms I mean makes with a normal, we call it as angle of reflection. Angle of incidence we denominate as angle I, and angle of refraction reflected, we call it as angle R. Coming to the laws of reflection, there are two laws of reflection. The first one is the intended the instant ray, the reflected ray, and the normal ray lies in the same plane. Here we can see the instant ray, the reflected ray, and the normal were in a same plane. Whatever the condition would be, either be it soft or hard surface, the reflected the ray, the instant ray, the reflected ray, and the normal ray will be in a same plane. Coming to the laws of second refraction, the angle of instance is equal to the angle of refraction. Here we can see the angle of instance is equal to the angle of refraction. If we move the angle of incidence, automatically the same angle will be appeared to the angle of refraction. This we call as angle of these two are laws of refraction. Coming to the types of refraction, there are two types of refraction: regular refraction or irregular refraction. Irregular refraction is also called as scattered or differ, sorry, scattered refraction. Regular refraction or irregular refraction we can see here. In regular refraction, parallel light rays of an object falls onto a surface at the same angle of incidence. As the surface is smooth, the angle reflection is parallel to the each and every ray. We can see it in some mirrors and water surfaces. In mirror, we can see the table reflecting onto the mirror, and here we can see the lake reflecting the hills and trees. Coming to the irregular refraction, parallel rays of an object falls onto a different angle of surface as the surface is rough. Here we can see the surface is rough. All the light is coming parallelly, but due to the roughness of the surface, it is the angle is different for each and every light. So the image would be not clear. Some of the examples are sand surface or ripple ripple water bodies. Here we can see that the tree and the house and grass are rippled here. The image is not perfect. Thank you, ma'am.
Prabhakar, explain me what is Snell's law.
Ma'am,
Snell's law,
Snellen's law, ma'am.
not Snellen's law, Snell's law, of which is related to reflection.
reflection. Not much idea, ma'am.
Yeah, our topic is about reflection,
Reflection.
right? Then you did not come across it. No.
Not much idea on that, ma'am.
What is diffraction?
Diffraction. The image. The
Okay. What is total internal reflection?
total internal reflection.
Yes.
In a in a glass, when we shine a object, for example, optic cables, ma'am. Optic cables run under in total internal reflection. It reflects
Tell
light.
me what is.
Uh,
Don't tell me the uses of total internal reflection. Tell me what is total internal reflection. What is it?
a complete reflection inside a medium, ma'am, like glass, water,
Tell me in terms of optics.
ma'am.
Tell me in terms of optics.
Optics.
You said as if reflection which is happening totally inside it is called total internal reflection. How does it make a sense?
Ma'am, I can't hear you, ma'am. Hear you, ma'am.
Tell me the proper concept of total internal reflection.
I'll give you an example, Krupakar. What is critical angle?
What is critical?
What is critical angle?
Angle.
Critical angle of
Reflection. Almost complete answer.
I need to give example of critical.
Angle.
Critical of what?
Critical
Sir?
angle. Critical angle.
Of
What is a critical angle?
in example, ma'am, water or like that.
Now, what is critical angle?
A angle beyond an angle beyond the incidence ray.
No, Krupakar. You have to go back and refer.
Ma'am.
Okay. Go back and refer.
Okay, ma'am.
None of the answers are
We'll move to the next
appropriate.
student.
Yes, Nikhila, share
You
your
can
screen.
start your presentation.